I was working with Dave Jewett, and we were at MIT, and just starting graduate school, and he was my advisor, and I was looking for something to do, and he said, well, you know, the outer solar system looked kind of empty. And I said, okay. So I was like, and he says,
Empty.
Empty. And he pointed out that the inner solar system, which is basically from the orbit of Jupiter inward toward the sun, he says this is full of stuff, like the terrestrial planets, lots of asteroids, and so on. But from Jupiter outward, there's not much except 4 giant planets and this odd thing called Pluto. And so the question was, he says, well, we really should see, is it really, really that empty? Or maybe it's really empty, or maybe it contains lots of things, but they're hard to detect because they're far away. And I remember, I said, okay, that's a hard thing to do, because by definition, these things, if they haven't been seen by now, they must be faint and hard to detect. And I said, it is a practical thing to do. And he said, if we don't do it, Jane, who will? So anyway, so that's so we set out just to see if the outer solar system was empty, and we kept going. Everybody kept saying, why are you doing it? There's nothing. We were able to pursue our idea because we were lucky to be at the University of Hawaii, and we had our own private telescope that belonged to the university. And so it was easier to get telescope time to do the observations we wanted. We applied for telescope time on National Telescope, and we got rejected every single time. They said, it's absurd, there's nothing there, so this is just stupid. With bigger science, that's harder to come by. And we just kept going until we found the Kuiper belt.
And Pluto?
Nah, sorry. Oh. Well, we found the first Kuiper belt, and then you can fit orbits after you have a few observations, and we found a few more, and then we noticed things that some of them have orbits very much like Pluto, and then by some calculation we came to the conclusion that there must be at least 10,000 things just like Pluto, on a bit smaller, but orbit-wise identical.
You were awarded the Kavli Prize in 2012.
Right.
For this work.
Right. And, well, if you want to call Pluto a planet, then you have to call all the other 10,000 things planets too. So it didn't seem to make much sense.
Right. And now you're working on this.
Yeah, interstellar object. So the top picture is a picture that I think everyone's seen in newspapers and Time magazine and so on. So that was the first interstellar object that was confirmed. It called Oumuamua. It came through in October 2017, and people had been expecting interstellar objects because our own solar system has littered space with lots of things. So we figured, all the debris in space, some of it must come through our solar system, but this was the first one that we could confirm.
Why is this the first one? I mean, we've been staring into the heavens for a long time. We've had...
Because it's difficult to find. This one was very faint, and it was moving very fast. And if you think about it, we only have systematic surveys of the solar system in the last few years. Before that, yes, people found things, but it was never a system.
Where was that? How far away was that?
Oh, this one was found just beyond the orbit of Earth. It came through from above the ecliptic plane, and it took a turn due to the sun, and then it just went back out.
Where did it come from?
Nobody knows.
How could we ever figure that out?
Well, people try to integrate the orbit backward to see which direction it came from, and that was all well and good until we noticed that it has a non-gravitational acceleration, which means that it can't be explained by gravity. So with that non-gravitational acceleration, all bets are off. You don't know where it came from.
And this one?
So this is a second interstellar object found. So it was found earlier, I think, August this year. And unlike the previous one, it looks just like a comet. So far it's behaving quite normally, just like other comets that we have seen.
Do you have a contract with Hollywood yet for any of this? No, I mean, but this is the perfect stuff, right? This is what science fiction is.
Aliens?
Right. So, I'm being a little... But what is the significance of seeing this? What does it mean to you as a scientist to see it? What does it tell us as mere Earthlings?
I mean, we've always wondered whether we're alone. The question is, are there other Earths in the universe, right? And we build space telescopes, and they get bigger and bigger, more complex, more expensive, and all with the goal of seeing these exoplanets close up, trying to see other solar systems beyond our own. Well, with these guys, well, big telescopes are nice, but you can just sit there and wait until they come by, and then you can see them with just little telescopes. You can even send a satellite to study them up close. So it's just an enormously exciting opportunity to study samples from another solar system close up. Hopefully, with the Kepler prices becoming more well known, that people recognize that you can pursue a crazy idea that you care about, that you're passionate about, and you can just pursue it, and just not because you expect anything at the end, any award or prize at the end of it. You just pursue it because it will be a cool question to answer, and if you're lucky enough, you get the right answer, and it's really neat, and sometimes people care about.